I was searching for a kind of bird sound generator. I found 3 circuits on YouTube. I want to refer to them, but I found that sound not ideal, though it worked very nice, I have to say that. And I made my own circuit here. This is on the breadboard. It's now driven by 3 batteries, 1.5 volt, so together 4.5 volt. That works nice, and I will tell more about it. I will also give a demo with the bench supply connected to this circuit. Well, it is of course, say, the classical Astabile Multivibrator. You can find many circuits about that on the World Wide Web. Also, say, the scientific explanation about how it works. I don't go so deep. I've made so many of these multivibrators, but they always have their, say, specific problems, not real problems, but anyway, when you make them. They don't want to start, they don't want to work on the frequency that you have calculated or so, but anyway, this is the schematic. In fact, it's very simple. One transistor here, NPN transistor, another NPN transistor. The frequency is set by this capacitor, that is C2 and C1, and there is here an interval circuit. I found out that when I connected the output to the input in this way, via big value electrolytic capacitor, we could get a kind of time relay. Delay, that's what I mean. This is of course, the whole idea here is of course a time dependent circuit. This is the time dependent capacitor. Here is the time depending resistor. Anyway, and it means that this oscillator starts to hick in a certain way. It hicks on a frequency that's given by the value of this capacitor here. And of course the whole idea here, say that capacitor gives out its charge here to the base of the first transistor. So when it gets depleted, it will have an effect on the base voltage, and that has an effect on the frequency and also on the time where, say, the whole oscillator stops. On a certain moment it stops, the capacitor gets depleted again or charged again, and then the whole circuit starts to work again. And then I mean oscillate on a certain frequency given by the values of C1 and C2. You can change them for other frequencies. I've now made them, I've taken them in a very small value, because I wanted to get a kind of bird sound. That means a high frequency that is here realized by this 10 nanofarad cap and this 56 nanofarad cap. And when you make, say, a difference between these two caps, you get another time relation. And that's visible here. Now it's oscillating at the moment. During a certain time the oscillator is switched off and on, and here there is a longer time and here's a shorter time. Anyway, that's, say, a kind of way to change the sound. When, say, one of the transistors is, say, pierced off, it cannot transport that certain frequency etc., etc. So you get very sharp pulses in that case. Anyway, schematic again, and then we can look how it works in practice. This is on the breadboard. You see the, say, interval potentiometer, that's here. That is this potentiometer here, interval. It's responsible for pinching the first transistor off and on. Here is the frequency potentiometer. That is this one here, 47K. And you can also, when you want to do experiments, change this 27 kilo ohm fixed value resistor into a potentiometer of 47K. It will mean that you have a bigger frequency span. So at the moment it works on 3 batteries, 1.5 volt. So this is a kind of bird sound, and I want to demonstrate the effects of the interval potentiometer that's here. When I touch it, you can directly see and hear the effects. Anyway, so I turn it now a little bit, and we have to wait till that capacitor is discharged or charged. So now the oscillator oscillates again on a very bad frequency, but anyway, change it a little bit. Now we have the same situation here and here. Now I want to go to a higher interval. So the electrolytic is now, say, depleted and charged up during a different time. Let's see whether we can get this even for a longer time. So this is how the circuit works. It's now working with that 4.5 volt battery. And now give the schematic here not 4.5 volts but 12 volts here on that power supply here. So, and we can also see that the whole circuit works nice. I have to say there are certain positions on that potentiometer, that interval potentiometer, where the circuit does not work, so be aware of that. You can do your own experiments. Well, let's listen again. Higher voltages in general give shorter times, higher frequencies. Now we have to wait till the capacitor is charged and discharged. We'll try to get to a higher frequency. Okay, turn the potmeter again. the interval potentiometer. Let's see what can happen. Sound is quite annoying. Anyway, it's a demo. So I think now we are on a position of the potmeter where it does not want to completely discharge. Now it works again. Well, is that all to tell? Yes, we are going back to the battery. Does it still work? Always important. Yes, it still works. Well, I want to go to a high frequency. So, well, and here we can wait again. I've turned the potmeter to a kind of low value. Will it start again? Well, yes, it starts. It takes, of course, time before it starts again. So I stop the quite annoying sound now. Schematic again. And we can finally look at the scope. It works quite nice. Of course, it is a kind of experimental circuit. You can change the frequency responsible capacitors. C1 here and C2. You can use here a potentiometer to get more variation in the circuit, etc., etc. So, thanks for watching. I think this was more or less all to tell. Let's listen again.